Hello there, this is Team Ziggiotti and this is our presentation for CPE 355. We are going to talk about different mapping techniques in cache memory. First of all, what is cache memory? This is a computer memory that helps in reading data faster since data stored within the memory are the ones that are frequently used. Static Random Access Memory, or SRAM, is used on the cache since it gives faster access to data rather than the Dynamic Random Access Memory, or DRAM. In this case, it is more expensive and there is less storage compared to the DRAM, but the use of SRAM provides better speed. With this, the introduction of multi-level cache helps to lessen the cost of a processor and also improves its performance. Now let's look at the levels of cache memory. Level 1 cache is located in the processor itself. It runs at the same speed of the processor and it is the fastest among the levels. If the CPU cannot retrieve data from the level 1 cache, it looks at the level 2 cache next. This cache is slower than the level 1 cache. Then, if data is still not present in either level 1 or 2 caches, the processor looks at the level 3 cache, which is the slowest among the three. Finally, if data is not present among the caches, the processor searches in the RAM.
Mapping techniques. There are three different mapping techniques. The first one is direct mapping. Direct mapping is considered to be the simplest out of all the techniques. Direct mapping maps out each block of main memory into only one possible cache line. In other words, it assigns each memory block to a specific line in the cache. If a line is previously taken up by a memory block, when a new block needs to be loaded, that old block is thrashed. That's the reason why thrashing of lines is a possibility. The next one is called associative mapping. Associative mapping is considered a more flexible technique compared to direct mapping, wherein basically any block of the main memory can reside in any cache block position. This means that the word ID bits are used to identify which word in the block is needed, but the tag becomes all of the remaining bits. This enables the placement of any word at any place in the cache memory. And lastly, the third technique is called the set associative mapping, wherein blocks of cache are grouped together into sets. This mapping technique allows a block of main memory to reside in any block of the specific set. The good thing about this technique is that it addresses the drawbacks of the possible thrashing in the first technique, which is the direct mapping. It combines the best of direct and associative cache mapping techniques.
Difference of mapping techniques. Direct mapping. A block can be placed only in one position in a cache. Not flexible enough. Hit ratio is poor as there is only one fixed location for each main memory location. Direct map is the fastest. Associative mapping enables each main memory block to be loaded by any line of the cache. Hit ratio is increased as main memory location can take any location in any cache. No index field. The entire address must be used as a tag, therefore increasing the total cache size. Set associative mapping. The cache is divided into numerous sets of blocks called sets. The hit ratio is more compared to direct map cache, and amount of energy consumption is less as compared to associative cache because of limited no-tag patterns need to be searched. Relevance of using different mapping techniques. must remember that cache are used to make processors faster by reducing the memory of the performance wall, and it is made of small storage elements known as block. Thus, the different mapping techniques will determine the arrangement of blocks and will then tell us how fast can we access the cache and how the latency could be reduced.